There it is.
Told you every day that we have an assignment that we complete a lesson. You're going to come in the next day and do daily quiz. Daily quiz is going to be usually 1, 2 middle of the road problems. These are literally taken from the extra problems right next to your examples in the teacher's edition of the book. So it's the same thing that we did last time. Now remember, I need to be able to find these easily, quickly. You see this big stack of notebooks over here. Algebra 2 and Pre-Calc had tests today. So they turned in their notebook or binder, and I real quick flip through their note packet, make sure that all their notes are filled in, that they did everything we did in class. I check their assignments to make sure they're actually doing them, and I check their daily quizzes. Okay? So if you don't have this labeled at the top, 1, 2, daily quiz, if you don't have the score clearly indicated, it's going to take me 5 times as long to go through it. If it looks like too much of a mess, I might not even look at it. I'm just going to toss the notebook off to the side and say, fix it. Okay? Probably the easiest way to do it is right on the back of your homework. Okay? Oh, we were writing down our exponent properties last hour. So, please, oh please, I would like you to do your second daily quiz. Doesn't have to be a big deal. It's open notes. It's open book. Look at your homework. Just shut your noise holes. That's all. Open resources. Look at problems that look just like it. I guarantee there's an example just like this in your notes. Go ahead and use them. I just want to know what you know. Not what your friend knows, not what your neighbor knows. What you know. Okay? See, I'll take care of that real quick. See how many bodies we got in the room. Slowly getting those names taken care of. All right. Oh, I see a Thomas. I know where Levi is. Haven was back here somewhere. Haven moved. There you go. Okay. Heath. Okay. Booger 2. Dylan. Dylan was down the middle. It's either you or you. Okay, that's Dylan. All right. Savannah text me. We got Ashton. Okay, I get you and you mixed up. Jocelyn had messaged me too. Ava was over there. Nevaeh was back there. God, I'm pairing the wrong two kids over and over. Okay. Abby. Jesse was in the back. Trey. Where's Trey at? Dropping like flies. Killian. Dominic was back there. I don't remember that now. Isaiah. Grace. Cohen. Elena was back there. Keeley was this way. There we go. Sailor was that way. Tyson. All right, last time I did this too. Sophia and Natalie. Which one's which? Well, you're both here, so okay. Abigail and Jacob, wingman. Okay. All right. They should be fairly quick. Is anyone still going? Cool. All right. Order of operations. Almost. What else do I need to add to it?
The directions for the
Okay. Okay. Our order of operations are parentheses, exponents, multiplication, division, left to right like a book because they're technically the same thing. Division is a lie. Addition and subtraction, left to right like a book because technically subtraction doesn't exist. So, what do I do first? Get those parentheses. 2 to the 5th plus 25 divided by 5. Next. Just say it, like, exponents. Okay. So 2 to the 5th. Anyone know what 2 to the 5th is before you press the button on the calculator? Okay. 32 plus 25. Okay. I tell kids in every class that I have, all the way from algebra half through pre-calc, I got almost the whole high school curriculum. Know your squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you can memorize. Because you will run across them so often. All right, next up, division. And finally, down to the end.
How'd you get 25? With the parentheses. Oh.
Because 11 plus 14 is 25?
I thought it was 10.
Oh.
That's where I went
Okay.
wrong.
All right.
I thought the 11 was 10.
So you added 24 divided by 5?
Yes, that's what I did.
Okay, 24 fifths plus 32 is 160 fifths, so 184 fifths. Still works. But you can point to your exact error, right? So, did you have 184 fifths? Or, so what would that be? 24 fifths, 4.8 to 36.8? Okay, yeah. That would only be one off because you know exactly where you went wrong. Then, second one. If I'm going to evaluate, what did we say last time you should do before sticking any numbers in there? Parentheses. Replace each of these with parentheses. Because if you don't, I guarantee you will screw up exponents and negatives. Okay, x, we said was what? We got a 3, and y was 4. Okay, now do order of operations. That's it. Like, it's same thing, you just one step in front. 3 squared is 9. 4 squared is 16. While I'm at it, we know that's going to be next, right? Just because I'm running out of room here, I'm just going to put the 6 in. Okay. Next up, divide. 16 divided by 6 is Uno. All right. House rule. You've all played Uno, I hope. do you play the official rules that say if you have a wild card and you can play it, you have to play it? The official rules say if I'm sitting on like a red card and a wild card, it's a yellow 2. The official rules say that I have to use the wild. House rules usually say, I'll just draw because I want that wild card as my last card so no one can block my Uno, right? I didn't know that until I played it on a phone. And then 9 plus 6 plus 1. Ta-da. Okay. So we need pointage. Here's how we're going to do this. Pretty simple. I'm going to say 2 points each. For the final answer, the work. The final answer, the work. And then we're going to throw 1 point just kind of hanging out in there as a floater for, oops, I said 14 plus 11 was 24. You still did the process right. You still have the steps written out correctly. You did everything right except basic arithmetic. Okay. And it was 1 error and exactly 1 error. I'd call that a 4 out of 5 any day. Okay? But if it's multiple errors, if we're goofing in multiple spots, or if it's just a big honking procedural error, like maybe right here you said 5 plus 25 is 30. 30 divided by 5 is 6. That's like you ignored half of what you were supposed to do. You just ram numbers together. Now, okay, now we're looking at a 3 out of 5 or a 2 out of 5. Now it's a bigger deal. Okay? Any questions on how to score them up? Make sure that your score is boxed in, circled in, something easy for me to see to make it easier to go through that giant stack of notebooks. Next up, the homework. I had a handful of kids come in and ask just a couple questions, usually about words. Talk to me. Speak now or forever hold your pieces. Is there anything? Tomas.
There was one question where it had like an A and a B, and then the B was really confusing.
Part A, Part B, probably 36.
Yeah, B6B.
Okay. Pearson's not the greatest. It won't let me zoom in on it. So you have your book or your online book. But Part B says, how many cubic inches to the nearest tenth of a cubic inch does a fluid ounce of juice fill? So in Part 1, you found what the volume was. And if I remember right, it was about 24. It was about 24 cubic inches. So if I know that the volume is about 24 inches cubed, and then the can says that there's 12 ounces, you got to read the can. It's not in the words itself. Okay? How many cubic inches does a fluid ounce fill? Well, if 12 ounces makes 24 cubic inches, every ounce makes 2 cubic inches. Just take 24 divided by 12. But if you don't go back and read the can, read the picture, you're wondering where that information is. Okay? More? Don't have to be super brave to just be like, 26. That's all you need. If it's something that you are not sure about, ask. Okay? Nothing? Say it.
Well, I said we had to do 35, right?
Oh.
I think it was on there. I mean, I put it down on the paper. But
Yeah, we did.
35 was kind of confused. I don't like story problems, but it still was like it was like science. I'm not doing that.
Okay. 35, you said? 35. Way down. Don't start with me, friend. Okay. An object's momentum is defined as a product of mass times velocity. Write an expression for the momentum of the object. It just said the product of. Hey, look, words. Turn words into math. Section 1. The product of mass and velocity. Okay. Mass times velocity. You're going to get real familiar with that one because y'all in physical science, you're going to see that a lot. Momentum is mass times velocity. You'll see that one an awful lot. Case in point, if I started running down this aisle straight at Thomas and tried to stop myself, would that require more or less energy than if Killian ran down this aisle at Thomas?
I would say more.
I'm probably about 3 of Killian, at least.
Yeah.
Okay? More momentum, because there is more mass moving even at the same velocity. Okay? A whole lot of you are probably either you just got your license, maybe you got your permit, you're going to start driver's ed, whatever it is. Have you tried the difference between going 50 or 60 and just stomping on the brakes and locking it up in a car versus a big truck or an SUV?
Huge difference.
Big truck, not so much truck speed.
Yeah, don't do it, but like
50 or 60 and lock up the brakes?
Yeah, don't
if you
do
got
that.
better front brakes than rear brakes, your rear end's gonna slide out.
Also, you shouldn't do that to your car.
Yeah.
Okay. Now, unfortunately, deer are not the smartest critters.
And trucks are the ones that got better.
Oh, yep. If you are privileged to have this thing that not everyone has, you are okay. Yep. Spoken like a cis white male. So, the idea is that the more mass something has, or the more speed it has, the more momentum it's going to have. You can have something that is going very slow but has a lot of mass. It's hard to stop it. Okay? A semi rolling down a hill at 20 miles an hour versus a little Prius rolling down a hill at 20 miles an hour. One of them is going to do more damage. Okay? Write an expression for the momentum of the object. Okay, mass times velocity. You're going to see that an awful lot in physical sciences here. Make a table to find. Okay. Make a table to find the momentums of the vehicle at these different velocities. So they're going to tell me mass times velocity, mass times velocity, mass times velocity, a bunch of butt cheeks. And in there we're going to put, it's 1,000 kilograms, a metric ton. And we've got different velocities, 15, 20, and 20. Oh, we only need 3 of them. At 15, 20, and 25. Y'all remember how decimals work? If I take something times 1,000, what do I do to the decimal? Just move it over 3 places. So 1,000 times 15 is literally just 15,000. Is 20,000? Is 25,000? Now it says its momentum is defined as mass times velocity. It doesn't actually tell me what the mass and the velocity, okay, it does tell me meters per second, kilograms. Physical science, you're going to learn about difference between joules and newtons, watts versus ohms. You're going to learn about a lot of that different stuff in physical science. For now, as long as you had just written the numbers, I'm okay. We're good. But, Sailor, you say, words. I don't know how to do that. What has transpired in the last 46 hours?
What? I don't even know what that is.
I'm pretty sure there was a Spartan time. I'm pretty transpired, occurred, happened.
Oh.
Okay.
Food lunches.
Okay, we need to do English class too. It means you've had 2 days with which to wander down before school real quick, pop in after school. If you have a couple of minutes during your Maroon 2 class, that's my prep, come on down, I don't care. Maybe you have academic life skills. Maybe you have a resource room, that block. Cool, come on down. Lunch and Spartan time. And, y'all on remind, you got a tutor in a pocket. Who in here, be honest with yourselves, like, see that this is a common occurrence. Who in here did not do 35 on your own? Like, you either just didn't do it or you copied it. Be honest. Or someone just told you how to do it. Okay? This is why I said homework should not be a part of your grade. That's why it's completion only in here. Homework doesn't tell me what you know. It tells me what you know, what your sister knows, what your mom knows, what Google knows, what the solutions I have posted on my website know. Be honest with yourself. Don't just copy something down. Don't just skip it. Don't BS it and put, well, I'm just going to put like an M and a V on there and walk away. Like, try it for real. And if you don't understand it, then ask. I want you to ask. Okay? My Algebra 2 right now is crushing it. Every night I'm getting 15, 20 messages from 20 kids. Just asking real quick. And when I have 2 or 3 kids asking the same question, I sketch out a YouTube video and send it to them because I know that's a problem. I want you to ask. You are going to learn better if you ask. Can't just stare at it. So, I'm going to try to knock out 2 sections today. I don't know if that's going to happen. I really don't know if that's going to happen. It has been 6 years since I've had freshmen. It's been probably 8 or 9 since I've had Algebra half. I don't know what the pacing is going to be on this. We might crush 2 sections in a day. It might take us all day for just this one. I don't know. We're just going to go until we can. At AT. I hope you all have that note packet handy. We're going to keep coming back to it every day. Everything that we do in class, you are turning in another, what's today, Thursday? Week and a half. Week and a half. You'll do your first quiz. You will turn your notebook that has your assignments and your daily quizzes in it, your note packet. You're going to turn all those in. Y'all know how awkward that's going to be if you don't turn that in? Like zeros across the board, and that's the only thing in the grade book? Especially freshmen, you haven't had that yet, where you get locked down in Spartan time for years on end because you haven't figured out you need to actually do your work. You haven't had to repeat a class because you failed it. Get it right now. I don't want you to go through that pain and misery of having to repeat a class with freshmen. Just last hour, I had 2 kids in here complaining because they had to go and retake a class from freshman year with freshmen, and they are absolutely hating it. You'd swear someone was pulling their fingernails off one by one for how much they're complaining. Okay, you don't want to be in that position again next year. So, the real number line. Here's what we mean by real numbers. It's a number you can find on a number line. I can point to it. It can be a pretty number. It can be a butt ugly number. It could be 6. It could be 97/17. It could be negative 2.8593862. It could be pi. It could be negative 6 square root of 39. It could be e. Who was that who was in here yesterday with the e? So, okay. I'd said pick a variable, just throw a variable down. E. And I just like start. E is actually a number. You won't learn about it until Algebra 2, though. Okay? E is a number, just like pi. They are all numbers that you can find on a number line. That makes them real. There is such thing as an imaginary number. Come up to Algebra 2, and we will tell you all about it. Yes?
How many numbers of pi do you know?
3.1415926 is where I usually stop, because 3.1415926. I was teaching in Rapid, March 14th, 2015, 9:26 in the morning. We had a Pi Day celebration. It's the Pi Day of the century. It only happens once every 100 years. So we had a big party, like every math teacher in the building. We were doing games and stuff. We got free pies donated by people in the community and just geeked out all day.
Wait, so it happened at 9:26 exactly?
Yeah.
Nice.
Well, there's more after that. We could have gone so many seconds, but I think that's where we, yeah. After that, I don't care. I always just use the pi button anyway. So, the simplified form of each expression, well, do you remember what square roots look like? What they mean? Well, yeah, that's a square root. I know that. What does it mean?
Where if you take that number that it equals, it's squared.
What squared makes this number? What does it mean to square something? Times itself. Okay, so if I say the square root of 81, 9. Because 9 squared will make 81. This also works for fractions. I want you to write this down. A square root of a fraction is a fraction of square roots. A square root of a fraction is a fraction of separate square roots. So when I say the square root of 9/16, well, that's the square root of 9 over the square root of 16. Just take care of them separately. Okay? This is going to come back to us for years and years and years and years. So next to this, if I were to say like the square root of, let's see how many know their squares. Who knows their squares off the top of the head? Yeah?
That thing called phone, what is that?
Cis means cisgender. You are the gender that you were assigned at birth. White. Most of South Dakota. Male. Assigned that gender, you are a dude. It means white dudes are incredibly privileged. Means get away with a lot of things that any other marginalized community is not. Which leads to racism and homophobia and bigotry and misogyny and all those things that make you a trash person. So, what is the square root of 169? 13. Well done. 49. Okay, I'm betting more people know that one. 7? Yes. Okay. So I would just call that the square root of 169 over the square root of 49, which is 13/7. Okay? So I'd like you to take care of that bottom row. A, B, C, D. Let's see how many of you know your perfect squares. They all are. What times itself makes 1, dude? If you got to break out a calculator and guess and check it, okay.
Like it's no.
What times itself makes 1?
One.
1.
Multiplied by itself when you square it.
So what squared makes this number? Next year, you move on to Algebra 1. You're going to talk about simplifying these when they're not perfect squares. And we should have 8, 5, 1/6, and 9/11. Okay? That's it. Also, I want to come back up here. Oh, that's the thing. I want you to go back to this and maybe highlight it. A little bit of vocabulary. It's not just called the square root sign. It's called a radical. Because there's more things than just a square root. There's a cube root, fourth root, ninth root. There's a pith root. Okay? Again, all the way up to Algebra 2, you start talking about logarithms and rational exponents. You'll learn about these. The thing inside the radical is called the radicand. Y'all remember back to day 1. Said, I'll treat you like an adult till you show me I can't. We're on day, what, 3? 4? We're getting pretty close to, I can't trust you to sit anywhere near the people you want to sit next to. I hate seating charts. But if y'all are going to act like you're 12, we're going to treat you like you're 12. Okay, these perfect squares we just talked about, yeah, that's great. But sometimes they're not all perfect squares. Sometimes you got to guesstimate it. Lobster eyes. Okay, this looks really freaky in inverted colors, but y'all seen lobsters or flies, anything with a compound eyes, you get up on them with a microscope, it's just a whole bunch of squares. Okay? Under the surface, or under a microscope, the surface is going to look like graph paper. It's just a bunch of squares. They measure the area of one of their squares and they say it is 386 square microns. That's itty bitty. Remind me, what do you know about squares? Okay. What about those 4 sides? They're all the same. The symbol for that is they all have a little line on them. Okay. All of the angles are also right angles, 90 degrees. There's a bunch of other stuff where the diagonals are the same. Opposite sides are considered parallel. All kinds of other stuff about them. But that's the important one. Do you remember how to find area of any rectangle? Any rectangle. Length times width, base times height, however you say it. So if a normal rectangle is length times width, but they're both the same, the area of a square is side squared. So when they say the area is 386 square microns, they're saying 386 is s squared. So you probably saw back in middle school, if I want to undo squared, what? What squared makes 386? Okay, let's head to those calculators. Can you find a perfect square that's really close to 386? Figure it out. Start pressing buttons. Okay. Well, there's a question mark there. I asked what are perfect squares right next to it. What are perfect squares really close to this? 361, what is that? Okay. So method 1 says, I know 19 squared is 361. That's below this. What's 20 squared? I'm betting that's above it. Okay. 20 squared is 400. And our number is right in between them. Is 386 closer to 361 or to 400? You subtract, right? 400 minus 386 is 14. 386 minus 361 is 25. So it's 14 from this one and 25 from that one. Since it is closer to this one, I'm going to say it's about 20. That's what the book wants us to do. They're going to say because it's closer to that one, it's about 20. Now, method 2, Tomas.
Yeah.
What'd you do? You started rattling off a whole bunch of numbers. What'd you do?
Square root is it?
Just press the friggin' button, right? Okay, you actually do the square root of 386, and you're going to get about what? So, everyone got your calculator on hand, the calculator you are going to be using, and press the button. Everyone better be able to find their square root button. Because every calculator is a little bit different. A right view calculator, you're going to type square root, then the number. But if you're using maybe a basic calculator on your phone, you'd have to hit 386 and then square root sometimes. It all depends on how it's programmed. So I want everyone to make sure you can find that and it comes up with 19-point junk. Okay? Just make sure that you have that number.
Is this one of those ones where you have to close the parentheses?
You don't have to if you don't have anything else after it. But it's always safe to just get in a good habit.
Yeah, I can't find the square root.
Ruh-roh.
Where is
Yours is in a secondary function up here. So I'm going to have to second square root, then type it.
What is the square root button on?
Okay. You're going to start working with more complex calculators than before. Look in the lettering above the numbers. Okay. The buttons themselves, they got something written on them. Look in the other color right above the buttons and see if you can't find that square root. Yep. So you're going to have to hit second or shift or alt. There's going to be some button, probably the same color as those words, as those symbols. You're going to have to hit second this in order to get the button to work. Yes, ma'am?
I did that. Enter and it says I need to.
Oh, okay. So that's because there's two kinds. This is the nth root of. This allows you to do third root, fourth root, 28th root. You want just plain old square root.
Oh, I did not see that.
Yep.
Thank you.
Okay. I like it when we ask those questions. So does everyone get the 19 point something? We all found the button. We know where the button is. We're good. Okay. Then I want you to wing it on 34. Square root of 34. About how much is it? Mm-hmm.
How you find it again?
In another color right above buttons. So I will have to second square root, then type. Okay.
So we just need that number.
Yeah. I just want to make sure everyone can find the,
I have a question.
Yeah.
Okay, so it's this button.
but you have to hit second. You have to hit blue button to do blue stuff.
Oh, So you press this. Does this come before the number?
Yes, because then it'll put a box underneath there that you fill in with the number. All right, everyone get 5 points some junk?
Yes, sir.
I hope. Okay. Then you say, what is this inception crap over here? We're going to talk about those different types of number systems. Do y'all know there's different kinds of numbers and they got different kinds of names?
Kind of, a little bit.
No, not like the name of the number itself,
Talking about,
but
like, the, numbers,
okay.
irrational, all that.
Uh-huh.
I get it.
I want you to come to this little oval in the very, 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 very center. In the beginning, there were natural numbers. It's like an N that's kind of doubled up, like that. It's an N that's kind of got whacked in the head, so you got double vision. Okay? It's a double N. It's natural numbers. Natural numbers, I call that Arkansas math. These are numbers that you can count on your fingers and toes. Okay? 1, 2, 3, 4. They're called natural numbers because you count with them. Okay? So the hillbillies can easily count on their fingers and toes. They can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I got 21. Wait. That's Arkansas for you. Okay? After that comes whole numbers. Whole numbers are natural numbers, but someone realized, well, wait a second, what if I don't have anything? Then I might need a 0. Okay? Do you see why the natural numbers are inside the whole number circle?
Yeah.
Why?
Because the whole numbers are still the natural numbers, but they're like modified.
Okay? The natural numbers are a more specific group of this. We call it a subset. So like if I were to say right now, every student in the room who is wearing shorts. Who is wearing shorts and shoes, not sandals. Doesn't that kind of subset it down? The kids who are wearing sandals and shorts, they're still wearing shorts, so they're still part of that bigger group. Okay, subsets. After whole numbers, these are the ones you started learning about in middle school. I don't know why they use these. Integers. I'm assuming it's because I is the imaginary number. Just like we didn't want to use E as a variable the other day, I probably don't want to use I as a symbol if I is its own thing in math. Okay? It's a Z, like a double Z. Integers. Positive and negative whole numbers. Dot, dot, dot. -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Okay? Those are integers. Positive and negative whole numbers. Both directions. Then, Tyson, you said something else too that was, what's another kind of number?
An irrational number.
Okay, rational versus irrational is where things start to split. Rational numbers, they do it with a Q because then you always know that it's a set symbol instead of a variable. Okay, it's like a double Q. Every one of these are a capital letter with double vision. Okay? A rational number. Next to this, if you would, please write, rational numbers are, no, we want dark purple. Dark purple, there we go. Rational means it can be written as a fraction. Rational. I can write this as a fraction. I can write it as two different parts. That makes it rational. I can compartmentalize it. So give me an example of a number that can be written as a fraction. Okay. Now, you might have just a straight up fraction, like 3/4. You said 0.3333333333. We all know that one. Okay. What is it? Now you know that one. Next to that, if you want to write, please, this is going to be repeating decimals. And terminating decimals also. So like just, oh no, lighter. 0.7. That's a rational number. Now right now, some of you are going to look at those like, those ain't fractions, those are decimals. Why are you saying this? How do I write, you know what? Let's even put in there -5. How do I make -5 a rational number? How do I write it as a fraction? 1 under it, right? Anything becomes a fraction when you put it over 1. Okay. We said we knew that 0.333333333333 was a fraction. It's 1/3. Okay, smarty pants. What's 181818181818181818? No. Honk honk. Okay. It's 2/11. What? That doesn't look, there's no 2s or 11s anywhere in there. How do you know this? There's a rule, you might want to write this, that says you take the part that's repeating. The part that's repeating is 1/8. Put it over that many digits of 9. So 1 and 8 are the part that's repeating, put it over a pair of 9s. 2 digits are repeating, put it over 2 9s. Reduce that. What's 18 divided by 9? 99 divided by 9. Okay. So, what if I had, y'all got a calculator, what if I had 0.731731, on and on and on and on and on. The part that's repeating is 731. What would I put it over?
Over 3 9s.
999, and then you reduce it. So, 731 over 999. I don't know if that reduces because 731 isn't divisible by 3.
Well, yeah.
It might just be that. Okay? It might just stay that. Okay, what about, you said terminating decimals, 0.7. What place value is this?
Which one?
Oh, that's
The tenths.
The tenths. Literally, tenths. 7 tenths. That's it. 0.7 is 7 tenths. So what if I had 0.78921? What place value does it go out to?
the mill.
Well, count. Tenths, hundredths. So this is 78,921 hundred thousandths as a fraction.
Do we have to simplify?
Now, you would always simplify them down if you can. But that's why rational numbers are such a big circle, is because they encompass a crap ton of numbers. You notice there's nothing that's going to contain them besides the big box. The big box is called real numbers. Real numbers, section 1.3, real numbers, is every single number that you could actually find on a number line. Real numbers, not imaginary numbers. That's in 2 years.
Can you give us one example?
Algebra 2. Well,
It's an imaginary number.
so you could do geometry, and you could do Algebra 1 and geometry next year, Algebra 2 junior year. Yeah. So come back in 2 years.
Sullivan, can you give us an example of an imaginary number?
I. It's the square root of -1. So here's why. If I said, what's the square root of 9? What times itself makes 9? And 3 times 3 makes 9. What else times itself makes 9? Times itself. Did you all forget that negative numbers exist?
Oh my god.
-3 times -3. -3 times -3 still makes positive 9.
Oh yeah, I forgot about that.
So if, whoa, no, not that color. If -3 squared makes 9, then, and 3 squared makes 9, then the square root of 9 is both a positive and -3. Both of them. So what if I said the square root of -9?
3 and -3.
Square root says what times itself. 3 and -3 are not the same number. You can never take, no, negative times negative makes positive. We just said that. You can never make a -9 by multiplying something by itself. It does not exist. That is not possible. It breaks math. So we make the idea that the square root of -1 is I, the imaginary number. It does not exist.
So are they all I then?
Anything that has a negative in a square root is now I. Okay? So,
So what are the imaginary numbers on? Why don't you?
come on. Come back to it. Booger, wingman, knock it off. Outside of this circle of rational numbers is going to be irrational numbers. Irrational numbers are things that you can't write as a fraction. They're a decimal that goes on forever and ever and ever. There's no pattern to it. It never repeats. It never stops. Like pi is one of them. Square root of 2. Y'all got a calculator? Do square root of 2. Or how about we just had square root of 34? Square root of 34 didn't have a pattern to it. It was just a string of numbers. That is an irrational number. And just because we ran into it yesterday, Grace, I also want you to put on there E. Pi is about 3.14. E is about 2.72. It goes on forever, just like pi. Okay. These are all of the real numbers. These irrational ones, they're butt ugly, but I can still find them on a number line. You could still point to 3.1415926 on a number line, right? It's right there. It's in between 3 and 4. It's right there. So it's real. Okay. Maybe Tyson can point to his friend. There's no one here. Tyson's friend is imaginary. Tyson doesn't have a real friend. Sorry, dude. Okay. Now, next to that, outside of the box, these are my imaginary numbers. And I'll just say, come back in Algebra 2. They're floating outside the box. We don't know. We don't have those yet. Hey, your friend's back. There you go. Now you have a friend. We were pointing to his imaginary friend. So, it's true. So,
What about the entourage when I came in though?
Oh yeah, that was pretty cool. You had like your own groupies. Okay. We write all of this down because now, I hope you wrote it all down, because I'm erasing it, I ain't coming back. Now, classify these numbers. Tell me which of those sets do these numbers belong into? And you want to get as specific as you can. So, 15. It's Alabama math, right? It's all the way in the center at natural numbers. Well, yeah, we should say Arkansas. They're a little worse than Alabama. They couldn't even come up with their own name. They just looked at Kansas and said, we'll be Arkansas. So this one is going to be naturals. But look at all the other sets that naturals belongs to. So you get to write them all down. Now do you see why you want those symbols? It belongs to the naturals, the whole numbers, it belongs to the integers, it belongs to the rationals, and it belongs to the reals. 15 gets to go everywhere. 15 is the popular kid. Gets invited to all the parties. Okay. Negative 1.4583 stops. That's a terminating decimal. Where do terminating decimals belong? Jeez.
I don't know, I just said, like, like, kind of like sounds like termination. No, wait, that's the wrong word.
That's like there's a word.
A terminating decimal means it stops. Terminate means to end.
Same thing. Trash and burn in a fire. Toy Story.
This is a rational number because all terminating decimals are. But hey, go back to that figure again. Where do rational numbers also belong?
Real numbers.
They're real numbers.
What's the sign?
Okay. Square root of 57. Thank you. Grab the calculator. If you don't know off the top of your head whether that's one of your perfect squares, grab the calculator, press the button. Does that decimal train keep going? So it goes forever. Does it have a pattern? Does it? So it's not terminating and it doesn't have a pattern. It's just a decimal that goes forever. What kind of number is it? Irrational. But, freshmen, you should know this more than anyone else. Your irrational friends, they're still real. They might get you put in jail this weekend because they're irrational and they make very poor decisions, but they're still real friends. It's still an actual person, unlike Tyson's friend over, like, no. Levi's here. We got your imaginary friend is now hiding under the table in shame because maybe they don't want to be associated with you anymore.
Tommy never did really like you.
Shade. So those four, please. Tell me. We've got all these number sets. We have all these number sets. You tell me, what does square root of 9 belong to? What does 3/10 belong to? Okay, go back to those number sets and tell me. What do those belong to? Okay?
Can we just do the one this time?
No. We do all four because all four have a different flavor. You notice two of them are square roots, but one of them can be simplified. One of them's a fraction, one of them's a decimal. There's a reason we have all of those. Okay, there is a big honking diagram here that we filled in. We can, thankfully, all of this is being recorded. You can do that, but you can also just, like, if you don't want to copy those parts, you can always screenshot and print those parts. Okay. Oh, you don't have to print it at home. You never need to spend your own money. You print it out here. Okay. Okay. Remember, argue it out with your neighbors. Make sure that you're on the same page. You want to start with what is the most specific this is, and then it's everything outside of that too.
Oh wait,
Okay. Now, I might have gone a little overboard with the whole like plus minus thing, talking about how imaginary numbers are. Oops. We're just going to say square root of 9 is just 3. Okay. I know I had said it was plus or minus 3. We'll get to that later. But there's the idea that if the radical is already there, you only use a positive one. If you put the radical there as part of solving, then it's plus or minus. Again, later. That one will be next year, Algebra 1. Okay. 3, well, that's the whole gamut, right? 3 is a natural number. Look, 1, 2, 3. Or if you're my kid, 1, 2, 3. Because I got to use 2 hands for everything. 3/10. What is it? What? No, don't give me an equivalent number. What sets does it belong into? It's a rational number because it's written as a fraction, and it is also a real. So reals and rationals. Could I say it's an integer? Can it get more specific? Could I write that as a positive or negative whole number? No, it's just a fraction. Terminating decimal. Hey. Terminating decimal. That was one of the things we wrote down. What is it? Terminating decimals. Rational numbers again. Square root of 12. Go and grab that calculator, double check. Square root of 12. Does it come out nice?
No.
Goes on forever. Does it have a pattern? So that is only a real number because it's irrational. It doesn't have any of the other bubbles. It's not rational, it's not an integer, it's not a natural, it's none of those other things. It's an irrational number outside of the bubble. But your irrational friend is still a real friend. Real in the sense of physical and existing, not real in the sense of true to you. Because your irrational friend might be just trying to screw around with you. Comparing them. Go back to that very last thing we did. We didn't know what square root of 12 was off the top of our head, so we just pressed the button, right? That's how we compare these. What is an inequality that compares square root of 17, 4 1/3? If I don't know what those are off the top of my head, grab a calculator and take square root of 17, 4.12310 ... versus 4 1/3. Well, if I put 4.12310 and 4.33333, now that I've seen them together, I can compare them. A comparison is not an equal sign. Y'all remember Pac-Man? Or the alligator or the shark? However you learned it, fix the ding-ding. Remember those?
Yeah.
Okay. Some people always looked at it like the dinosaur or the alligator or whatever. I was always partial to Pac-Man. What does it always do? Eats the greater number, the bigger number. So if I now know, there's way too much talking going on. If I know that this is 4.1 something, and this is 4.3 something, now I know that that one's bigger. I will write it like this. You still write it with the originals, but you might have had to go to decimal land to get that comparison. So do the same thing down here. 4a, square root of 129 and 11.52. Who's bigger? Who's got more clout? Figure it out. Are they? Are they exactly equal? Or are they just really close?
That's the question.
1/3 is 3 repeating.
Oh, thanks.
3 repeating.
17. That's
But 4.1 stuff, 4.3 stuff. Say you're going to get a job. Which one's better? Getting paid $10.15 an hour or $10.20 an hour? Right? They're really, really close, but one is more. One is greater. Okay. I don't know off the top of my head exactly what 129 square root is, but I know it's 11 point something, and I know it's less than halfway between 121 and 144. Square root is 12. So I know that that's going to be less than 11.52. What is this? 11 point what?
3 something.
3 something? Well, 11.3 something is less than 11.5 something. So that's actually how you write your answer. Okay, don't write the decimal parts, write the originals, because you're comparing that number, not the number close to it. Okay? Is there another inequality you can write that compares these? Spoiler alert, there is. What could I write that's still correct instead of just this is less than that? Come on. Was there any other inequality that looked like this? Kind of like it? Similar to it? Same thing, different shoes?
Like a fraction, maybe?
Well, it's got a bar in it.
I don't really know. It must be a fraction.
Remember those? Less than or equal to?
Yep.
Remember solid circles and open circles on number lines?
Yeah.
Okay.
Can you-
So, there are other ways to write them. Graphing them. I have square root of 4, 0.4, negative 2/3, square root of 2, and negative 1.5. That's a lot of stuff. Put them in order, least to greatest. Y'all got a number line handy? Then just make one.
What number do you think we should go to? I'll go to 2.
You do not need to go very far.
I'll go to 2.
So, everyone got that calculator handy and ready? If you don't remember off the top of your head, what is the square root of 4?
2.
Okay. So, I'm going to say square root of 4. 0.4, where does that go?
In between 0
Well,
and
in between 0 and 1, right? Not quite halfway.
a little bit less than.
Negative 2/3.
I'm gonna go in between 0 and negative 1.
Okay. 2/3 of the way there, right? Square root of 2. About 1.4. Grab the calculator and double check. And a negative 1.5. So, there's my set in order. That's all it is. It's just comparing them. Find out which one's bigger. If you're not sure, put all of them into decimal land. Because if I put each of these into decimals and I say 2.0, 0.4, negative 0.6 repeating, 1.4, negative 1.5, they all go out to the 10th place now. I can just compare them, one on top of the other. Okay, this is how you compare numbers. Turn them all into decimals so you can get a comparison down and dirty. So which one was it?
C.
Part C? Okay. Do the same thing. Get them in order. Where did you get this?
Online.
Okay. The second kid I've seen with that, and I'd never seen that brand before this year. Okay. Sounds about right. She sits right around there. Argue it out with your neighbors. Turn all of these numbers into decimals. Because if you're all in decimals, then they're all in the same type of system. You can compare them. It's kind of like if I wanted to know what costs more, I'm not going to have something that's in dollars, something that's in Canadian dollars, something that's in euros, something that's in yen. Right? I'm going to convert all of them into the same thing so I can actually compare them. If someone says this costs 20, well, is that $20 or is that 20 euros? Those are two very different amounts. Okay. A decimal or a radical or a fraction. Those are all very different systems. So turn them into the same thing. Wait, is it 2.52 or 2.2? I forgot that one.
There's negative 2.1.
2.25, not 5.2.
Yes, 2.5.
Okay. Wait, is it 2.5 or what is it?
I swear I just had it on my calculator. It's 2.236.
Okay. The whole purpose of this is to get them into the same system. If they're all in the same system, now I can put them in order. Who's first in line? Who's the least up there? Negative 3.5. Why is that before negative 2.1? Larger negative, meaning you're further in the hole. It's worse to owe someone $20 than owe them $5, right? I hope.
Where does that say negative 2.5?
Okay. You're jumping the gun here. If I put these all in numerical order, this, and then 2.2, and then 3, and then 3.5, those weren't the actual numbers, were they? You put them in the actual numbers. The originals were not negative 3.5, it was negative 7/2, then negative 2.1, then square root of 5, then square root of 9, then 3.5. That's the answer. Don't leave them in decimal answer. Okay? The decimals, those are your work boots. You want to use those to get stuff done. You don't wear your muddy turd kickers at home, okay? Slobbering a bunch of cow pie up on the table. I put my feet up on the table. It's my house. I'm going to do what I want. Of course, it's kind of backfiring now that my 4-year-old is copying everything. So, there you go. So, you see it's already on the 1-4. I don't even have any example problems because this is usually pretty quick. I also expected to get through 1.3 and 1.4 today. Clearly, we're not going to do that. So I'm going to cut it off there. That also means the assignment that's on plan book right now is wrong. So what you're going to do is not annoy me for 9 minutes so that I can fix the assignment and then make sure that it's good on plan book and send it out on Remind. Okay?